This next video here is about the inverse normal distribution. Before we start, I want to talk about percentiles and quantiles. The kth percentile of a set of values divides them so that k% of the values lie below and 100 minus k% of the values lie above. Wow, what does that mean? Demonstration. C would here be defined as, okay, if you can see that little C there, will be defined as a 30th percentile. Now that will be an actual value, and below that value you've got 30%, as it says there, 30% of the values below that, and above that you've got 100 minus 30, so 70% of the values above that. A quantile is the same sort of concept, but it's defined there as a decimal instead of a percentage. So it's the 0.30 quantile and the 30th percentile. The 50th percentile, by the way, okay, would be there, and that is actually known as the median. And in Maths Applied, I'm not sure if it's in the course in the future, in the general maths, but we define the 25th percentile. It's called the lower quartile. Not sure whether this is necessary or not, but I'll just mention it. The median is the 50th percentile. And the 75th percentile is known as the upper quartile. 75% of values lie below it. Alright, now let's look at the inverse normal distribution. I'm going to start here with just to show you a question. It's sort of related to what we just did then. If x is normally distributed with a mean of 13 and a standard deviation of 4, and the probability that x is less than k is 0.71, find the value of k. So what's that actually asking? It's actually asking what's the 71st percentile or the 0.71 quantile. So what's this value k here, below which 71% of the values lie? Now to find that value, we use a thing called inverse normal distribution, okay, or inverse cumulative normal distribution. And here's how it works on the calculator. This will enable us to find this value k, below which 71% of the values lie. So, on to menu. So write this out. Menu, oops. Menu. Then it's probability 5. Distributions 5. Once again. And choice number 3 is inverse normal. And then it asks for area. So that's the area less than the value we're trying to find. Always less than the value we're trying to find. I'll get to that later in a later question. But for now, please realise that it's less than that value is 0.71. So the area is 0.71. The mean, whoops. Equals, according to the question, what was it again? It was 13. Standard deviation equals 4. So we enter those in. 0.71, 13 and 4. We get a value of 15.21. It's two decimal places, 15.21. So therefore k, that point there, is 15.21. That's the value beneath which, below which 71% of values lie, which means 29% of values will be above that. Now, a more practical situation. The lengths of fish in a particular river are normally distributed with a mean of 28 and a standard deviation of 2.34. Find the maximum length of fish that must be thrown back if the shortest 30% must be returned to the river. Okay, so here we are. The shortest 30% is there, okay, below that value k. So let's make sense of it again. Find the maximum length of the fish that must be thrown back, so if the shortest 30% return to the river. Okay. So the maximum length of fish must be thrown back. So what's that limit? What's the largest fish that must be thrown back, given that those smallest 30% have to be thrown back? So I'm trying to find that value k. So it's the same thing again. It's inverse normal. So menu, I won't write it down this time, menu 5, 0.53. Our area is 0.30. Our mean was 28. Our standard deviation, okay, so getting that from back in the question, remember, there's standard deviation, there's the mean, was 2.34. Okay, so if we put those into our calculator, same thing again. Sorry, we've already done that, haven't we? We're already there. Beg your pardon. So we now put that in our calculator. Area 0.30, mean 28, standard deviation 2.34, and we get 26.77 centimetres for that answer. Last question. The time taken for Year 7 students to read a certain page of writing follows a normal distribution with a mean of 163.2 and a standard deviation of 20. Find the speed with which 90% of the students exceed in reading the page corrected to decimal places. This is where the language gets difficult. Find the speed with which 90% of students exceed in reading the page. Okay, so if 90% of students exceed this speed that we're trying to find, okay, there it is. Then we're shading in this time. I've shaded in the area greater than K. Alright? Because 90% exceed, that means go over this time. Exceed that time. Alright? Now the important thing to remember with the normal distribution, the inverse normal distribution questions is this. So next step would be, once we're there, to go menu, 5, 5, 3. Now our area, this is crucial guys. The area is not the greater than area. Okay, we're not interested in that here in our calculator. Okay, even though that's the question. What we're interested in is this area here. It's always the less than area that goes in our calculator. So it's 0.10. Okay, our mean, going back to the question, was 163.2. Our standard deviation was 20. And if you place that in the calculator, so it's 0.1, 163.2 and 20, we get 137.57 seconds is our answer. So that last example is important because, as I mentioned, it's the greater than area. Okay, that should give you the opportunity now to do questions on page 603. Questions 14 through to 16. Away you go.